All right, so today we're going to do a little bit more work with binomials. So the first one here is just a warm-up, so if you actually want to pause the video and give that one a try on your own, and then you can check your answer. I'll go ahead and do it, but again, just hit pause and then see if you can do it on your own for those of you at home right now, and then see how you do with it, okay? All right, so this is how we would do it then. Right, so we would have 4w to the fifth, and then the 5 is from Pascal's triangle. We've got 4w to the fourth. In comes the negative 3, right? So we can see the 4w going down in power. And then I'll just go ahead and finish it out here. So we've got 5, and then 4w, negative 3's to the fourth. And then the last term then would be negative 3 to the fifth. So that's what it would look like. And of course, now we can do some simplifying, right? So 4 to the fifth. So again, the most common mistake on these problems is right there at the beginning, forgetting to actually raise the 4 to the fifth, right? So we actually want to raise the 4 to the fifth. And so 4 to the fifth is, hold on a sec here because there's some multiplying here. I'm going to get my calculator out. So 4 to the fifth is, 1024. This is going to be a really big one. So 1024 w to the fifth. And then this one's going to end up being a negative, right? So we've got 4 to the fourth, right? So 4 to the fourth is 256. But then I have to do 256 times 15. So that is going to be 3840. So 3,840 w to the fourth. And then on the next one, I've got 4 cubed, right? So 4 cubed is 64. And then I've got times 9 because of the 3 squared, and then times 10. So 64 times 90, basically, right? That's going to be 5760 w to the third. And then I'm going to have 4 squared is 16. All right, so I want to have 10 times 16 times 3 to the third is 27. So that one's going to be negative. So negative 4,320 w squared. And then I've got negative 3 to the fourth. So that's going to be 81, right, times 20. So 5 and the 4. So 1620. So 1620w, and then last but not least, negative 3 to the fifth would be minus 243. So just a little bit of practice for you there. Okay, so what we want to do today is actually figure out how we could maybe just jump to a particular term. Is there a faster way to figure out what the term is that has w squared, right? So I know from expanding it out that the w squared term is the negative 4,320 w squared. But boy, it sure would be a lot nicer than if I could just get that value quickly, right? And so it came from this term right here. So if we think about, what's happening in each term as we expand, right? There's always going to be that Pascal number, and then there's going to be the two pieces raised to powers, right? So in other words, I'm going to have the 4w, and it's going to get raised to some power, times the negative 3 is going to get raised to some power, right? And then out here in front, I know there's going to be a Pascal number, and it is going to be, in this case, 5 choose something, right? Because it was raised to the fifth. So the question then is, how do I fill those in? And in this case, right, since we know we're looking for the w squared term, we know then that the 4w must have been squared, right? Because that's how the w would get squared. So once we know that, that actually helps us kind of complete the puzzle. So if we come back up here again and look at this particular term, right? Notice that if 4w is squared, then that means that the negative 3 had to go to the third. And the best way to figure that out, or to know that, is that those are always going to add up, right? 2 plus 3, those exponents, 2 plus 3, always add up to whatever the overall power is, which is 5. And then one other little thing to notice is that 10 here, right, is 5 choose 3. Right? This 10 was 5 choose 2. So what you can notice is that whatever this number is, right here, matches that second power. So notice that the 3 matches the 3. Right? So what we now know then is that I can fill that in right there. So I can very quickly get to that particular term. Okay, and we'll see a couple more of these here. But in general then, whenever you're expanding out a plus b to the n, right, if I don't know what the upper power is, I at least know then it's, going to be n choose, and then it always starts n choose 0, right? Where n is that overall power, and then n would come the a, right, and it would go to the nth power, and then I would have times b to the 0. We don't ever really write that because b to the 0 is 1. Right? And then the next term would be n choose 1. A is now going to go to the n minus 1, right? And b is going to go to the first. Right? And then if I do the next term, I'm going to have n choose 2. Right? It's just going to keep going up. But then the power of a is going to drop, so now it's going to be n minus 2, and b is going to go up, so it's squared. Dot, dot, dot. Now I know I said do the first 4 and the last 4, but I think that's enough just to get the pattern here and to save us on time. But if you notice then, right, if this is choose 0, then the second term is to the 0. If this is choose 1, it's 1. If this is choose 2, it's 2. And then the other thing to note, right, is looking at each of those exponents, right? N plus 0 is n. N minus 1 plus 1 would add up to n. N minus 2 plus 2 would add up to n. So we can see kind of those patterns just in general, right? So it says the term a to the 8th times b to the 4th would occur in the expansion of what binomial? Now, there's actually more than one probably answer, but just in terms of A and B, right, you could say, well, if I'm thinking about it's a binomial that's A plus B, the way that I would know what it's raised to is, again, by just looking at, well, what is 8 plus 4? 12. So I know that if I raised A plus B to the 12th, that somewhere in that expansion would be the A to the 8th, B to the 4th, right? So that's actually the next question, right? So it's saying, okay, well, if that's true, then there's going to be that spot where it's A to the 8th and B to the 4th. And so the Pascal number is going to be 12 choose, right? And so you know it's 12 because the power is 12. And then we always just match up, boop. This, whoop, hit the wrong button there. Have to get the highlighter. There we go, 4 and 4, right? They match up. So really then, the coefficient, we didn't have to actually generate all the terms. We could just jump to that term, right? And so we jump straight to that term, and we know then that that second power on the b is just going to be what the choose is. So then I can just come in here to the old calculator and do 12 choose 4. So 12 choose 4 is 495. Right? So now I know that that number out in front is actually 495. So 495 is the coefficient on a to the 8th, b to the 4th. Right? So that's the coefficient that I wanted, 495. So if it asks you for the whole term, you would write 495, a to the 8th, b to the 4th. If it just wants the coefficient, you can just write down 495. Right? So let's do another one. If I want to calculate the coefficient of a to the 4th, b to the 6th, All right, well, I know that somewhere along the line there's going to be an a to the fourth, b to the sixth, and this is in the expansion of a plus b to the 10th. So sure enough, 4 plus 6 adds up to 10, so that checks out. And then we're going to have that Pascal number out in front. So since it's to the 10th, we know it's going to be 10, choose, and then again, we always just pick that second one, 10, choose 6. And so 10, choose 6 is... So 10, choose 6 is 210. Right? So 210, and so there it is, so 210. Okay. Now, the next question says, is there a coefficient, right, of another term that is also 210? And so, of course, we have certainly noticed that Pascal's triangle has that nice symmetry to it, right? So is there another place besides 10, choose 6 where you have the same coefficient? And so if we wanted to, we could come in here and use our slider trick that we learned. So we could change this to 10, choose A, and we could let A run from 0 to 10. Right? And so when we do that, so we're looking for, right, we're looking for 210 as the Pascal number. So if we come in here and we scroll right there, 10, choose 4 is 210, and then 10, choose 6 is also 210, right? So, okay, let's come back here. So the coefficient of which other term is the same? Well, it would be 10, choose 4. Well, what do you notice about the 4? The 4 actually matches, right? So then if we had a to the 6th and b to the 4th, right? That would be the other term that would match that, right? And so it actually turns out that you can use either the 4 or the 6 here, and you'd get the same answer because of the symmetry, okay? So whenever you expand one of these, you actually, just for consistency's sake, I always just say it's the same as the second one, but actually you could have picked the first one. So they end up being the same because of the symmetry. One way to think of it is if you had 10 objects and you wanted to choose 4 of them, it should come out the same number as if you had 10 objects and you wanted to choose 6 of them. And the reason is because if I choose 4, I'm not choosing the other 6. So if I think about how I'm counting those up, right? Choosing 4 of the objects versus not choosing the other 6 should be the same thing. So, all right. So finally it says in the expansion of a plus b to the n, what is the coefficient of a to the n minus k, b to the k, right? So that's the same as some other term, right? So in other words, then, if I think about what this is, right, the Pascal number would be n choose k, a to the n minus k, b to the k, right? So the k's would match up. But it would also turn out then that this would actually be the same as n choose n minus k if a had been to the k and then b was to the n minus k, right? So those then would have matched up. So they actually would have been the same thing. I'd get the same number. So, all right, just a little clever trick there. All right, and then this last example here before you try some on your own, it says write this expression using sigma notation. So it's actually going back here to the very beginning and saying, is there a way to write this big mess out using sigma notation? And so again, remember that this sigma notation is that big funny looking symbol, right? And then what we do, right, is at the bottom, we tell what value to start with, and then at the top, we'll say where to stop. And then we have to tell what we're going to add up. So if we come back here and look, right, what are we adding up each time? Well, if I look at, say, this one over here, right, when I added up this term, I had a Pascal number, then I had 4w to a power, and then I had -3 to a power. So if I think about that, that's what's happening every time, right? I had a Pascal number, which is 5 choose, say, R. Then it got multiplied by 4w to a power, and then that got multiplied by -3 to a power. So if R is the thing that's constantly changing, right? R first was 0, because I would do 5 choose 0. And then I would do 5 choose 1 and 5 choose 2. And I would do that until I got to 5. Right? That's a 5. It kind of looks like a 6. So let me rewrite it. There we go. Right, so this is saying I'd start with 0 and I would keep going. Okay. Well, we also now know that that R, right, there, should match up with what's up here. So that would mean that the R would go up there, which means then that if that's R, then the other power that's on 4w is 5 minus R, right? Because we know that those two powers should add up to 5, since that is what we were raising it to. So this is a really, looks really gross, but remember, all this is really saying is, hey, if you took R and let it be 0, then right, the first term would have been 5 choose 0, 4w gets raised to the 5 minus 0, so that's 5, and -3 gets raised to the 0. And so sure enough, that is that first term, 4w to the 5th, because -3 to the 0 is 1 and 5 choose 0 is 1. Right? And then the next term would be 5 choose 1. Now the 4w would get raised to the 5 minus 1, because I'm letting R be 1. Right? So then this would be to the 4th. And then the -3 would be to the 1st. And then I would just keep doing that, right, until I got to when R was 5. So that is how we can actually write this using sigma notation. So it's very fancy, and it makes you look really smart, like you know lots and lots of cool math, right? Okay. Now, if you were in class, I would say, okay, now work on these, and I'm going to come around and see how you're doing with it. But obviously, since you're watching this video at home, I will actually walk through the first couple with you, all right? And then you can try the rest on your own, okay? But I'll at least try the first couple with you just to make sure you've got it down, okay? So it says, can you find the term containing t cubed? Can you find the term containing t cubed? So again, it's raised to the 6th, right? And so again, if you wanted to pause the video right now and try this, and then unpause it, see if you get it right. So we know that it's going to be 6 choose something. We know that 2t is getting raised to some power, and that 5 is getting raised to some power. Right? And so we basically just need to fill in all those little blanks I just put there. And so the key is that we want the term that's t cubed. So when I look here, here's the only t in this problem. So the only way t could get cubed is if this was a 3. Right? So we'll go in there and fill that in with a 3. Well, if that's a 3, we know that the two powers have to add up to 6, right? So 3 plus 3 would give me 6. And once I now know that that's a 3 up there on the 5, then I now know that this is a 3 right here. So just like that, we actually know, we know the power and everything that we wanted. So we do want to probably go ahead and multiply that out, right? So we know the full term. So we're going to have 6 choose 3. So we've got 6 choose 3. Whoops, I'll go to the other calculator. There we go. So we've got 6 choose 3, and that's 20. Okay, so I've got 20. And then 2t is cubed. So remember, that means the 2 got cubed as well as the t. So 2 cubed is 8. And then I've got t cubed. And then the 5 gets cubed as well. And so 5 cubed is 125. And so the last thing to do then is just multiply those together. So 20 times 8 times 125. So 20 times 8 times 125. Oh, 20,000. There we go. So that's it, 20,000. So 20,000 t to the third. So the term that has t cubed has a coefficient of 20,000 on it after it gets multiplied out. Okay, so again, why don't you, if you want to pause the video and then see if you can figure out letter B, and then I'll put an answer up. So you can hit pause. Okay, and welcome back. If you actually paused it. If you didn't, then you just kept hearing me talk. All right, so same idea, right? So I want to come in here. I'm raising it to the fifth. So I know this is going to be 5, choose, fill in the blank. I know that 2x is going to go to a power. And I know that, and be careful on this one, negative 3y is going to go to a power. So we do want to include the negative there, okay? We do want to include the negative. So let me, whoop. That's not what I wanted. Hang on. Trying to cut it there. There we go. Just to move it down a little bit. Boop. There we go. All right, so now I just have to figure out what those powers are, right? So let's take a look. See? So what powers do I need? Well, I need the x to be squared, right? Because I want the x squared term and the y cubed term. So that means this must be a 3. That way the x gets squared and the y gets cubed. And I should double check it. 2 plus 3 is indeed 5, my overall power. So I'm good to go. I know that this is going to match this, right? So therefore, if that's a 3, that's a 3. And so there it is. I've got it. So that's the term that has x squared y cubed. So now the only thing left to do is multiply it out. So I need 5 choose 3, right? So I go in here and I get 5 choose 3. So NCR 5, comma 3. And you may have already had that one memorized by now, right? So 10. Start to see the same ones over and over again. So we have a 10. Again, don't forget that the 2 gets squared. So that'd be a 4x squared. And then the negative 3 gets cubed, so that's going to be a negative 27y cubed. That's why it's so important to bring that negative along so that now we can keep track of, was this term going to be a negative or a positive, right? When you're expanding the whole thing out, we knew that the signs alternated, so we could keep track of that. When we're just finding an individual term, you really got to keep track of that, right? So we've got 10 times 4 times negative 27. So 10 times 4 is 40 times negative 27 is going to be 1080. So negative 1080. There it is. So negative 1080 x is squared, y is cubed. All right. So again, I'll do one more here with you, and then I'll leave the rest for you to try and give you the answers later. I'll put them up on the canvas. But again, if you want to pause it and give this one a try on your own, and then we can do it together. So go ahead and hit pause. Okay, and I'm back. All right, so this time we're raising it to the 12th. Right, so we know it's going to be 12 choose something. The 2x cubed is going to go to a power, and the negative 3y is going to get raised to a power, right? So this one is a little bit sneakier because, as you may have noticed, right, we want the x to the 15th. And here, x is being cubed. So what number would I need to put up here so that I would multiply a power to a power to get 15? Well, I'm going to need a 5, right? Because then 3 to the x to the third to the fifth would be x to the 15th. And then if that's a 5, I know that these two powers have to add up to 12. So that means this has to be a 7. That works out perfect. That would make y to the 7th. That's what I needed it to be. And that's going to make this a 7 down here. Now, I'm not going to ever ask you to do one that doesn't work out, right? So if this had not come out to actually be a 7, so that this was y to the 7th, then you wouldn't be able to do it. So I'm not going to ask you to do something that's not possible, okay? All right, so let's figure out 12, choose 7 real quick. So I've got 12, choose 7. So that's 792. So 12, choose 7 is 792. So 792. I've got 2 to the 5th, right? So 2 to the 5th is 32. And then that's x to the 15th. And then negative 3 to the 7th is going to be negative, right? So 3 to the 7th, probably not one that we know off the top of our head, right? So 3 to the 7th is 2187. Right, so negative 2187 y to the 7th. So now I've got this really tiny number, 792 times 32 times negative 2187. Okie dokie. So actually I'm going to split screen it because I won't remember those numbers. So let's see what we get here. All right, so we've got 2187 multiplied by 32 multiplied by 792 is that lovely number there, 55,427,328. It was negative, and that's my x to the 15th, y to the 7th term, right? So there we go. All right, so you can try those last couple on your own, and then I've also got some other problems for you to try on Canvas that I want you to actually turn in, and so give those a shot, and hopefully all that makes sense. It's just basically a quicker way to get to those individual terms rather than having to expand the whole thing out, right? So obviously, like in letter C there, if you're raising that to the 12th, you don't want to have to find all 13 terms. You want to just get to the one that you need. Now, to be honest, why you'd ever need it, I don't really know. But hey, why not? Math is fun sometimes, and we just